Hey everyone, my name is Agata and I am a part of the marketing team at MightyCon, and I would like to welcome you to our session on mass timber rigging. I'd like to draw your attention to the panel on the right-hand side of the screen. In the panel, you will find a handout section with a copy of today's slides available, the rigging design guide, and a question section. You can use the question section throughout the presentation, but we will answer any questions at the end of the presentation. And please watch for the Q&A in the follow-up email where we will answer all of your questions. So without any further ado, I'd like to kick things off by welcoming Neda Nadari, one of the engineers on the technical support team at MightyCon. Neda, over to you.
So mass timber construction has been on the rise in the last few years. But a very important and often overlooked part of building with mass timber is the lifting of the panels. And this is what we'll discuss today. Today, we'll go over MightyCon's new yoke anchoring system for mass timber lifting. It is a solution that is simple, safe, and tested in North America. Hi, I'm Neda Nadari, and I'll be your host for this presentation today. I'm one of the technical advisors for MightyCon Timber Connectors. We are a specialized mass timber connection system supplier based right here in North America. Today, we'll go over 3 questions. What is MightyCon's yoke anchoring system? We'll go over the hardware requirements. Why should the yoke anchoring system be used? Because it is a safe and tested solution in North America. And how to use the yoke anchoring system. That is with the design guide, which we'll go over later along with some examples. You can also see the design guide in the handout section of this webinar. So what is the yoke anchoring system? It is a rigging system that is unique to MightyCon. This screw hoist system consists of anchors that are screwed to the timber element using self-tapping screws. And what is a screw hoist system, you might ask? These systems rely on the withdrawal resistance of the fasteners used to attach the device to the panel. Compared to the other devices, which we'll go over later, these don't affect the wood appearances as much. Let's just see it more visually. You just place your yoke anchors respecting your edge distances on the panel you want to lift. You screw them out using self-tapping screws. Then you would place your sling and do your lifting. And removing the hardware is just as easy. You just simply remove your self-tapping screws, and as my French colleague would say, voila, you're done. The anchors come in different sizes for different capacities. There are a total of 4 systems that can lift most timber elements. For example, the mini yoke is optimized to lift structural insulated panels and prefabricated I-joist floors. As mentioned before, the anchors work with ASSY self-tapping structural wood screws. These are some of the most common screws used in the system. The full thread CSK, the full thread combi, and the EcoFast. The screw diameter sizes are different for each yoke too. The mini yoke that specializes in lifting lighter panels uses the smallest diameter size of 1/4 inch. And the yoke 5 ton and 1 ton uses a diameter size of 1/2 inch, and the yoke XL, which can lift heavier panels, uses a diameter size of 3/8 of an inch. We can look at the timber elements that the yoke anchors can lift. The elements are categorized based on their weight, with the heavier panel on the far right. The first is structural insulated panels, or SIP panels. Prefabricated wall panels, prefabricated I-joist floors, and different mass timber elements. These include floor or roof CLT panels, wall CLT panels, glue-lam beams, or nail, dowel, or glue laminated timber. You can lift other special elements depending on the projects. These are just some general ones. So what was the yoke anchoring system? It is a simple lifting solution for various mass timber elements. Now, why should we use the yoke anchoring system? Traditional building material like concrete and steel are widely used in taller buildings, so it's understandable that the lifting systems are more established. Additionally, they are much heavier than a typical wood element. This graph compares the weight of the three different materials in pound per cubic foot. You can see that wood is much lighter than steel and concrete. However, the lightness of timber shouldn't disregard the need for safely lifting timber elements. Just for context, a typical timber element can weigh approximately the same as a car. And don't just think any old car. Think of a fancy one you actually want to show off. So just like a car, the timber elements should be lifted with care. But most importantly, timber is a visual material. Mass timber elements are often used both as a structural and architectural element, which are left exposed. So you don't want to see the holes from the lifting devices. This is the Nest building at the University of British Columbia, where I studied and graduated from. This place was always a cozy area to study in, and not to mention they had some good food places. Compared to the other devices, the yokes are a heavy-duty system with strong fasteners. This means they can withstand external loads like vibration and wind. Since the system is screwed on using self-tapping screws, they are relatively simple to install. This reduces the amount of manipulation when you're using the system, which in turn reduces installation error. And most notably, this system is tested right here in North America. Full-scale testing was done on all the yoke anchors with universities in the US and Canada. All the testings were done up to the ultimate failure of the system using different timber elements. An on-site condition like anchor placement was simulated as much as we could. The results from all of this testing was used as a basis for the values in the design guide, which we'll see later. Now let's talk about the system's versatility. Before we went through the panels we can lift using the yokes. Here you can see that the roof and floor panels are highlighted in a simple post and beam structure, and the yokes you can use to lift them are listed here. The Yoke 510 is quick and simple with only 4 screws and can lift very heavy panels. And the Yoke XL is the most versatile one. It can also lift wall panels in addition to floor and roof panels. And it could be installed on the narrow edge and as narrow as a 3-ply panel. This way, you don't damage the visible side, which is what you want in exposed timber. You want to see the timber clean and nice. The Yoke XL can be used in a 4, 8, or 12 screw pattern. This increases the capacity from approximately 2,000 pounds for thinner panels to about 8,000 pounds for thicker panels. The Yoke anchoring system offers easier workflow. This is because the self-tapping screws can make the installation easy, and you can make a jig for fast installation, and the yoke themselves can be used multiple times. My tip, and pun here is definitely intended. For all the yoke anchors, the minimum edge distances should always be respected. The edge distances for a floor or roof panel is shown in this image here. And we just mentioned before we can make a jig. This is a rendering of a simple jig made out of plywood. You can use them to make the edge distances when you're doing repetitive lifts, and it can help make the installation faster. Now let's look at why the yoke anchoring system is cost-effective compared to the other devices available on the market. We have 2 other categories that we need to go through. The first one, based on Think with CLT Handbook, which is the most popular one, is the contact lifting systems like slings and threaded eyelet rods. For threaded eyelet rods, in-plant drilling is required and the holes need to be plugged after lifting. The other category of lifting devices are integrated lifting systems. These devices are mostly used in Europe and Canada, and the CLT panel is pre-drilled using a CNC machine. You place a steel rod in it with a sling. After the lifting is done, the rod remains in place and the hole is plugged. To lift the panel, there's always some preparation time with all of these devices. For most devices, including some in the screw hoist system that we just saw, you need to pre-drill the right diameter hole in the correct spot before installing the rigging device. And you need to maintain these systems all the time to make sure that they're not damaged. But believe it or not, you need to make sure that the pre-drilled holes are actually free from things like sawdust and other things that can get stuck in it. And most importantly, there's a cost associated with all of this, especially with the installation labor. So in the next section, the cost efficiency is defined as the labor costs and the time associated with it. Let's just jump in. The initial hardware cost of the yoke anchoring system is similar to traditional lifting devices like the threaded eyelet rod. Besides respecting edge distances, there's no major preparation needed. And you don't need to pre-drill since all the screws are self-tapping. So this way, you don't really need to worry about things that can get stuck in the pre-drilled holes like the other devices. So the installation time is lower, and removing the hardware is also lower in time and cost. And finally, there's no need to plug in the holes for fire and smoke prevention. Overall, the yoke anchoring system is most cost-effective once the hardware is on site and ready for installation. It's good to remember again that these systems also reduces the amount of manipulation and installation error, which makes it safer in addition to cost-effective. My tip. So you can use the yoke anchoring system with beams that have complex angles, or beams that are stacked side by side on a truck bed. If you were to lift those beams that are stacked side by side with slings, you would need to separate them a bit, lift them up, wrap around your slings, and then do your lifting. With the yokes, you just go on the ladder, use your self-tapping screws, and then do your lifting. And that's less time consuming. Here's why the yoke anchoring system should be used for mass timber rigging. It is a safe, versatile heavy-duty system that has undergone various testing, and all of these make it more cost-effective. Now we're going to talk about how we can use the yoke anchoring system. In this section, we'll go over the rigging design guide quickly, along with 2 lifting examples. And don't worry, all the information in this section is available in detail in the rigging design guide on our website for free as well. The first step is to identify the type of element that you're lifting. And that will be noting the wood species and relative densities. So if it's Douglas fir or an SBF panel. As mentioned before, these are the 7 main scenarios that we have lifting solutions for. The guide for the first 3 cases is still in development, but it'll be available early next year. The second step is to determine the factored total load of the element being lifted. Throughout the following slides, we'll go over the formulas that is used in the design guide. However, it's really similar for the Canadian guide. So for our Canadian engineers, we haven't forgotten about you. The factored total load can be found using the unfactored weight of the panel multiplied by the dynamic acceleration factor and an optional safety factor. The dynamic acceleration factor should be approved by a licensed design professional. For example, for a fixed crane, the kV factor is ranged between 1.1 and 1.3. And for a mobile crane, the factor is between 1.3 and 1.4. There are other situations that require higher kV factor, like moving in rough terrain. Now, an off-the-record tip, we don't really recommend lifting heavy panels with forklifts, and it's partly because the kV factor here will be really high. And KOS, which is our optional safety factor, it depends on the rigging situation. whether you're doing your rigging in an open space or a tight space like a downtown area. After the factor total weight is calculated, the right yoke anchoring system can be identified. So if you go to the design guide, you'll see tables similar to like this. This is a screenshot for a floor or roof panel. If you're using a yoke 1 ton, you can see that you have to choose the right specific gravity. Then it's important that you choose the right panel thickness because that'll correspond to the right fastener length and diameter that you're supposed to use. And finally, you can find the corresponding capacities of all your other parameters. If you want to use these tables, you have to respect 2 conditions. The first condition is to use load spreader during lifting. When you're using a load spreader, the length of the slings should be the same to avoid slack in the slings and to avoid uneven load sharing. So if you see this in this picture right here, you can see that the lengths weren't the same, so there's slack here. A good analogy of this is a 4-legged table. Even if one of the legs are uneven, the whole table will rock. It may find equilibrium on 3 legs, but as soon as there's a movement or a load, it'll start rocking on one side and only 2 legs will support the weight. It might not seem like a big deal for a table, but when you're lifting a heavy mass timber element, the second condition is the sling angle. The angle between the sling and the panel beta should be at least 60 degrees. And that's achievable if the length of the sling S is longer than the length of the panel L. If you don't respect these conditions on site, you need to reduce the capacity of the anchors with reduction factors. We'll see the reduction factors in a little bit when we go through the examples. Now for this section, we're going to go over 2 examples of panel lifting using the rigging design guide. The first example is lifting a floor or roof CLT panel. The panel is 10 by 40 feet with a density of 0.42 for an SPF panel, and it's 5 plies. And to make this example simple, we already know the site conditions. So we know that we're rigging in an open space. So our KOS, which is our optional safety factor, it's 1.2. We're going to use a mobile crane. So our dynamic acceleration factor is 1.4. And we know that our sling angles are at least 60 degrees, so we don't need to apply a sling angle reduction factor. We're using load spreaders properly, so no need to add a load spreader reduction factor here. And it's standard term loading. And that's about anything that's about 10 minutes. So if you have rigging that's more than 10 minutes, you need to provide a reduction factor of 0.86. Normally, the manufacturer would give you the weight, the unfactored weight of the panel, but you can easily find it with the dimensions and density like we did here. After we applied the factors, our factor total load will come to be about 10,000 pounds. For a floor or roof panel, you would typically use 4 yokes. So if you divide your factor total weight by 4, the capacity of 1 anchor should be at least 2,600 pounds. Now, if we go to the tables in the design guide, we have 2 options. The first is using a yoke 5 ton. You would choose the right specific gravity, so it's 0.42 for us. You would choose your panel thickness, then you can find your fastener and your corresponding capacity for 1 anchor. You can see that for 4 yoke 5 tons, the total capacity would be about 20,000 pounds. So we can easily lift our panel here. You might be thinking why we're choosing a capacity for the anchors that's much higher than we need. And the most important thing is when you're choosing the right fastener, a good rule of thumb is that the fastener should engage the most amount of plies possible. So the length of the fasteners are very important and the thickness of your panel. This way, the risk of delamination is reduced and the stresses are propagated properly. And why we know that fully threaded screws are a good choice for lifting. Another option would be using the Yoke XL, but with only 4 screws. So we do the same as before. We go into our right specific gravity, our panel thickness, and we can choose our capacity for the yoke here. The only difference is that the Yoke XL uses VGCSK fasteners rather than combis. To quickly recap, to lift a 10 by 40 feet SPF for a roof panel, we can use 4 Yoke 5 tons or 4 Yoke XLs with only 4 screws. Now let's find a solution for lifting a wall panel. Wall panel lifting is a bit different than floor and roof lifting. When lifting a wall panel, the rigging devices are designed for tilting as it's shown here. During tilting, half of the panel weight is on the ground and the other half is held up by the anchors. This is the governing case for the capacity of the anchors when lifting wall panels. When anchors are placed on the narrow edge of the wall panel, excess splitting of the wood can occur. This is because the narrow edge is always weaker than the side face. This is a picture from one of our testing done on the Yoke XL. You can see that it's placed on the narrow edge, and after the yoke has reached ultimate capacity, excess splitting on the narrow edge has occurred. So for our example here, the wall panel dimensions are 8 feet by 18 feet. It's again an SPF and 5-ply panel. And the site conditions are like before. We're in an open space using a mobile crane, and we know that our sling angle is at least 60 degrees. We're using load spreaders properly, and our rigging is less than 10 minutes. Using the same formulas as before, the factor total weight comes to be about 3,400 pounds. So this figure shows the weight distribution of the wall panel being lifted a little bit better. You can see that the anchors are only taking half of the weight of the panel in shear. When you lift the panel fully, the fasteners are working in withdrawal, and we know that they are much stronger in withdrawal, so we don't really have to worry about them after. So here you can see that I divided the factored weight of my panel by 2. So this is the number that I have to, this is the weight that I have to lift. And for a wall panel, you would typically use 2 yoke anchors. So again, you need to divide that by 2. And for 1 anchor, the capacity should be at least 850 pounds. If you go to the tables, you can see that the Yoke XL is the only anchor that can tilt and lift wall panels, and that's with all the 12 screws placed in. So same as before, you're choosing the right specific gravity, thickness, you find your fastener, then you see that the capacity for 1 anchor is about 1,000 pounds. So that's enough to lift our panel here. So my tip, for the same weight and size of a panel, longer screws are placed on the narrow edge. And again, that's because of the excess splitting that can occur. To conclude our example here, for our 8 feet by 18 feet wall panel, we can use a Yoke XL with all the 12 screws used. And sadly, we've come to our last my tip. The suggestions and detail in the guide are general, and all lifting work should be approved by a licensed design professional. Wait, I think I'm getting a message here. Oh, yeah. It's very important to know that the fasteners used for rigging should only be used once. This is because of liability and safety issues, so please stay safe out there, guys. To quickly recap this presentation, today we went over 3 questions. What is the yoke anchoring system? It is a unique Mightycon mass timber rigging system that is simple to use. Why use the yoke anchoring system? Because it is a safe, versatile, heavy-duty system that is tested right here in North America. And all of this makes it cost-effective. And finally, how to use this system. And that is by the Rigging Design Guide, which provides guidance in choosing the right system for different situations. I'd like to thank you for attending our webinar today. We'll now answer any questions that you may have. While we're waiting for your questions, this is a fun little project that we did. This is a building in Edmonton, Alberta. We made custom yokes for this very big beam right here. It was a little bit hard to use with slings to pick them up. You can see that it looks like a 5-ton, but it's much bigger. And they were used on the end grains of the big beams here.
For any questions that you might have, we will be answering them in the follow-up, but I just wanted to let you know that we are excited to offer a 15% discount on our heavy and mass timber handbook to all attendees of the webinar, with the discount going out in the follow-up email. Handbook includes our structural screw design guide, timber connection solutions brochure, rigging design guide, and exclusive to the handbook is a copy of the American CLT Connections Design Guide that outlines special design considerations with cross-laminated timber. And thank you for joining us today. As a reminder, you will receive an email on Monday with a recording of the session, slides, Q&A, as well as the survey where you can get your certificate of attendance. If you have any further questions, contact us at info@mightycom.com.
So I can see a question here. It says you can reuse the yokes but not the screws. And that's true. So the yokes themselves, you can use them multiple times, just making sure that you check them every time you use them. But the fasteners, we don't recommend using them again. And again, that's because of liability and safety issues. But you can keep your yokes. And someone else has said, why should we use the sling angles at 60 degrees? So for that, it's because the angles work better, the fasteners work better in withdrawal. So if you look at pure 90 degrees, they're much stronger in, but once it goes to 60, they're working in a combination of withdrawal and shear. And anything less than that will work more in shear, so they won't be as strong in that degree again. And so we decided to do all of the testing with the 60-degree angle. Have one last question. It says, when did you say the information on the mini yoke is coming out? That will be available early next year. We've done all of our testing, so now we just need to get the guide out. And if you look out for our newsletter or on our website, you can see it. You won't miss it. Yeah, I think that will be our last question for now. But again, we'll answer all of your other questions and put it on our website. Thank you again.